Hello and welcome back to my favorite people, and thank you very much for watching this lecture video. In last lecture, I mentioned that any carbonyl group, because it has unsaturated carbon in it, it can get involved in nucleophilic addition reaction. That means actually we can use this technique to make new functional groups and turn to the carbonyl to something else. And I practiced some example like in Grignard reagent, and we said it depends what we start with. If we start with aldehyde, we will get a secondary alcohol, while ketone it will give us a tertiary alcohol. So as you see, we can turn a double bond or carbonyl group to different functional group like hydroxide or alcohol. Now I want to actually extend this and to try to change the nucleophile, and as you see I can use oxygen, sulfur, nitrogen, hydrogen, or in carbon, and each one is going to give me unique product. In case of oxygen it has two hydrogens, and so we can attach, for example, we can attach to this group, and that's going to give us alcohol. Next step, we can attach RO to the carbonyl group, and that's going to give us an ether. Or actually we can use diol to protect any carbonyl group while we are running another reaction on the molecule. Now we can change oxygen by sulfur. The chemistry will be really similar to oxygen because they are in the same group. Now when you move to nitrogen it has like some unique properties that oxygen does not, and one of them is, imagine you make this bond, okay, and you get something like this. And so there's a sigma bond between carbon and oxygen, and there is an OH on a carbon, and also we can have hydrogen on oxygen on nitrogen. And if you eliminate these two, that's going to give you a new bond, which is going to be CN. So what happened? We turned CO to CN, and that's going to be that's going to be a new technically functional group, or we call it imine, and that it can get involved in different chemical reactions. And also we can switch nitrogen to hydrogen. In case of hydrogen, this time hydrogen it will come with a negative charge. So hydrogen will be the hydride or the nucleophile. And technically you are gonna saturate carbon by adding hydrogen to it. And so you can you can use this method to get a primary alcohol. Or in case of like a carbon, if you attach carbon to a carbonyl group, that's going to give you new carbon-carbon bond that you didn't have it before. Now you manage to extend maybe the length of the molecule or put some like a substituent on it. Okay, let's practice those examples. And first one, we're going to go after water. We can actually use water and add it to a carbonyl group, and we can then run the reaction under acidic or basic condition, and that's going to give us hydride molecule. Now, the hydrates are not favored unless you are dealing with a really simple, version of aldehyde molecules, and there are some reason behind it. One is the electronic, and the second one it will be the steric effect. And so as you see, if we start, if we run the reaction, and we will turn the ketone group, like a carbonyl group, to a hydroxide group, and the thing that is happening is, you take one CO bond, you break that one, you had a pi bond of CO, you turn it to CO, but this time it's going to be sigma. So pi turned to sigma, that's favored. But then when we look to OH really does not change. So the only thing that is happening here, we can say a CO, a pi bond, turned to CO, a sigma bond. Okay. I want to say this, that there is not much change with the energy here. So expect this one to be reversible. What does it mean? Reaction, it can happen in both directions. Okay, and that's one reason that we say formation of hydrate is not that much favored. And I said you do have electronic and steric effect as well. And let's look to the steric effect. So we have a carbon with sp2 hybridization, and because it's sp2 hybridization, the bond angle here it will be 120 degrees. Well, when I compare it with this carbon, that carbon is sp3. Bond angle in sp3 it will be 109.5. The bond angle got smaller. Now that it's smaller, these two groups, I'm going to highlight those two groups. Those two, they will be closer to each other. When they are closer to each other, they will repel each other. And so it depends on what you have there. If you have methyl groups, the repulsion it will be way more effective, and that means it's going to push the reaction back. Well, if you replace them by hydrogen, because hydrogen atoms are smaller, you do have some chance to get the hydride, and that's going to be the steric effect. How about the electronic? Hydrogen is less electron donating group than CH3. So CH3 is a stronger electron donating group than hydrogen. Now, if you donate electron density to that carbon, and the positive charge on the carbon, it will be less and less. And if it's not that much, then it's not going to go after lone pair of, like oxygen and water molecule. Okay. If we somehow saturate or we donate electron density to carbon, the will for gaining electron from water, it will be less and less. reaction can happen in basic or acidic condition, and I'm going to review those two. In basic condition, we mentioned this one, and so we have a base, and that is going to be the nucleophile, and then so in basic condition, it's going to go after carbon, because carbon, it has a positive charge, while the nucleophile is coming with a negative charge. And so the attack is going to happen on the electrophilic center, and we will get carbon, and that is going to be a tetrahedral. And now we have oxygen with a negative charge. Very soon it will be neutralized by taking hydrogen from water or from the solvent. Now we got hydrate, and okay, the bond angle from 120 now went to 109.5. Okay, so it's not much favored. And how about in acidic condition? Acidic condition, attack first step is going to happen on the oxygen, not carbon. Okay, this is the difference between them. Maybe I should use different color. Attack is going to happen on oxygen, not carbon. Why? Because it's acidic condition. In acidic condition, we will have a excess of H plus, or we will have a positive charge. We need to find source of negative charge. And where is the source? It's going to be on oxygen, because it's more electronegative than carbon. So we will have a positive charge on carbon, while there is a negative charge on oxygen. Hydronium ion will find negative charge on oxygen. So that's going to be the first side, technically to attack. Or we can say the nucleophile, and in this case, it will be the carbonyl group will go after H plus, and it will take H plus from hydronium ion. Now we got a species with a positive charge, and this carbon. Okay, this carbon actually now it has a huge positive charge, and the positive charge got actually exaggerated. Why? Because I can draw it this way. I can move the lone pair on oxygen in order to make oxygen happy. Now the formal charge on oxygen is going to be 0, but on carbon, instead of saying plus delta, I'm going to switch it to plus 1. Okay, remember? Delta means partial positive or negative charge. Now I made it plus 1, and because it's a plus 1, the hybridization here is going to be sp2. It's completely flat, and because it's a flat, it will be easier for the nucleophile to attack it. So next step, the nucleophile or water will attack it, and we will get an intermediate that it has oxygen with a positive charge, and that intermediate, it can lose one of these hydrogen atom in order to get hydrate. Okay, so the difference between the basic and acidic is like the starting step. In basic, we attack carbon, and while in acidic, because we have excess of positive charge or H plus, we will go after any species or any center that has a negative charge, which is oxygen, and that's going to exaggerate the positive charge on carbon. Okay, and I should use this color. Now, I mentioned this one before. I said when you are dealing with basic condition, keep this one in your mind. In basic condition, the charge can be only 0 or negative. Okay, if it's basic, and if it's basic, it will be either 0 or -1. If it's acidic, charge cannot be negative. Okay, cannot be negative. It can be either 0 or +1. Okay, now I said I can add more than one. I said I can change one of the hydrogen, replace it by alkyl group, and then add it to the carbonyl. And also we can actually use diol instead of just an ethanol, an alcohol. And let's go after those two. So this time we are adding 2 mole from alcohol, and also we are saying just H plus, no OH. Please add this one to your note. No OH. This one cannot happen. Okay, reaction is happening in acidic condition, and what's the product of it? The product is we get acetal. Okay, we get carbon that attached to 2 oxygen, and each oxygen attached to alkyl group. So technically, we got an ether. Okay, and yes, we have 2 of them, and plus water. And as you see, the reaction is giving you water as well, and it says it's equilibrium. Okay, and based on the Le Chatelier effect, I can actually drive the reaction to the right side by taking this product out of the system. So if you add any dryer, anything that there is ready to take water out of the system, and if this one goes down, in turn of the reaction is going to shift to the right side, and that's the way we can get an acetal. Okay, otherwise reaction is not that favored. Again, why is not that favored? And check this: the bond angle is 120, while here is 109.5. And if you are using, if you are using like a ketones instead of aldehyde, because you have more steric effect, the reaction is going to be, slower and slower. And okay, now let's talk about each step of this reaction. So first step of the reaction, regardless of what we start with, is addition of 1 alcohol to the carbonyl. If we use aldehyde, and the product that we get, we call it the hemiacetal. Okay, hemiacetal. What's the meaning of hemi? Hemi means half. half of the molecule is acetal because still we have OH attached to the molecule. And if we use a ketone, we call it hemi ketone.